Okay, so in this sections, we'll focus our attention on chain rule. So chain rule is actually, when there is composite functions given, and if we want to find the derivative of composite function, then we will use chain rule. Okay, chain rule will let us find the derivative of composite functions quite easily, by the way. So we will not prove the formula here, but we just apply that formula to solve problems. All right. So for example, find the derivative of y equals 4x cubed plus 15x raised to power 10. One way to find the derivative for this function is that you can write down this, 4x cubed plus 15x, 10 of those factors, and then you can multiply, all of them and find one function, find the derivative. Another way could be write these factors 10 times and use product rule for all those 10 factors. In either case, it is really painful. Okay, trust me, that's not fun. Writing those 10 factors and using product rule like so many times, it's boring. So you don't want to do that. So how can we solve these kind of problems? That is the main goal in this part of the lesson, all right? First of all, let us look at what is chain rule. Okay, chain rule states how to find the derivative of composite functions, and the rule is this: if you are given a function h of x is, if f of g of x, okay, h of x equals f of g of x, then the derivative of h, which is h prime of x, equals f prime of g of x, and then you find the derivative inside the parenthesis, which is z prime of x. This one is a little bit different than the other formula, but I think as we practice few more problems, I think it should be okay with you. All right. What this chain rule says is that the derivative of a composite function is the derivative of the outside, with the inside is staying the same, times the derivative of what inside is. For example, if we wanted to find the derivative of this example one, let me do method one here. So we have y equals, according to this formula, what we do is we find the derivative of outside functions first. That means we consider the whole thing as a one packet, one variable, okay? And we use the power rule for that, which means 10 4x cubed plus 15x raised to power 9. And then we find the derivative inside the parenthesis. That means 12x squared plus 15. That's what the chain rule tells us. Okay. In another word, I like this cartoon. Can you have a look here? So Courtney Gibson once, he came up with the idea is that this one is a mother function, okay, mother, and then this, he considered this inside part as baby inside the stomach, okay. Imagine that this one is a pregnant mom and this one is the baby. Inside is the baby here. This is the baby part. So what this Courtney Gibson, and I like this idea, many people find it easy to remember, differentiate the, mother first, which means leave the baby inside. So differentiate this part, use the power rule, differentiate the mother first, leave the baby inside, and then differentiate the baby later. That's what we did. We differentiate the outer function, 10 4x cubed plus, we leave the baby inside, and then we differentiate the baby later. Okay? So that's method one. And method two, you can do this way too. And you tell me which method you like, and I just follow that method, okay? So let me just copy the function here. Y equals 4x cubed plus 15x raised to power 10. All right. And you know that one thing is, if you have x power n, you can tell me the formula using the power rule is nx n minus 1, right? Because the variable here is x, the variable here is x. Now, if I ask you what is dxn over the, du, for example, then in that case, you cannot use the power rule because the variable are different. There is x and there is u. You cannot use that power rule. Okay, power rule is not applicable in that case. Keep in mind, we must have the same variable in order to be able to use the power rule, in order to be able to find the derivative. So in this case, what we want to do is, let us suppose that u equals 4x cubed plus 15x. If I suppose this part, the baby one, you know, the baby, the part inside the parenthesis, u, then your y will be u raised to power 10, right? Then y will be u raised to power 10. So now you can find the derivative du over dx, because u is the function of x, so we'll find the derivative of u with respect to x. That's going to give me 12x squared plus 15. And now this one is y is the function of u. Therefore, what you can do is you can write dy over du. dy over dx doesn't make sense because y is the function of u. All right. So dy over du will be 10u raised to power 9. Now the question is, we need to find dy over dx. That's the goal. So how can we combine these two things, and then we get this? Let us use common sense. If I write dy over du and du over dx, do you guys think they are equivalent? Okay, they are equivalent clearly because du is here in the top and du is in the bottom. So basically dy over dx is this one. So you see, we use a common sense, and the common sense actually help a lot here. So now substitute the value. Substitute values here. Values of this dy du and du dx. So if I substitute that, dy over du is 10u raised to power 9, and du over dx is 12x squared plus 15. Now again, substitute, because we are given y as a function of x. There is no function of u. We just introduce that function u in order to make our life easy. So in your final answer, always make sure that you change everything into x, okay? Substituting values of u back. So you're gonna get 10, u means 4x cubed. As you can see, our u is here, plus 15x, and then power 9, and 12x squared plus 15. So did we get the same thing? Let us check. This is our answer first, and this is our answer now using that formula. They must be same, right? Now guys, tell me which formula do you want, and I will follow that formula from now onwards. So now you have both methods. Just let me know which method you like. First, okay. All right, so, all right. Everyone prefer first. Okay, good. Let's work on example 2 now. We'll do a few questions together, and then one or two questions together and I'll leave it to you. Okay, so example 2, let's try part A. So what is given here is, let me just copy the question. F of x is 1 plus x cubed raised to power half, right? This one is given. So looking at this, this is, your baby. So you first differentiate the mother first, okay? Half, leave the baby and using the power rule, half minus 1. And then now differentiate the baby inside, which is a derivative of 1 plus x cubed is, that is going to be 3x squared. Done, that's it. It looks a little ugly. You may want to, simplify it a little further. So you're gonna get 3x squared over 2, and that will be 1 plus x cubed raised to power negative half. And again, the power, negative power, I don't like it. I want to change it into positive. So my final answer will be 3x squared over 2 square root 1 plus x cubed. Okay, guys, thank you. That's it. Now let's try part B, just for fun, okay? Same idea. Now, part B is a little bit complicated than part A, but we use, product rule and chain rule, and we'll be able to solve it without much difficulty. So we have 4x minus 2 raised to power 5, and then x plus 6 raised to power 4. Okay, first, Harmanjot, do we need to show all the steps? What do you mean all the steps? Like there is not much step, like in part A. If you want to do the, second method, yes, you have to show all the steps. And in part A, I think just this few steps should be fine.
Like in the first step, we can just show the derivative directly. Like it's
Yes.
simple to show the derivative directly.
Yeah.
Yeah. So we should not do these steps 1 upon 2, 1 plus x, 1 upon 2 minus 1.
No.
That's not okay. Thank you.
Yeah, you can go directly from here to directly to that step. Yes, no problem.
Oh, okay, sir.
Yeah. Let's do this part B. Now remember, this one is before you use the chain rule. This one is a product function, by the way, first. Okay. So this one is your u and this is v, because two functions are multiplied. Therefore, we need to first use the product rule. First, use product rule. That means f prime of x is going to be, your product rule is uv plus uv prime prime. We know the formula. We just copy uv twice and prime at one at a time. So now this means u prime means you need to find the derivative of this. Okay, so 4x minus 2 power 5 prime. I don't know, you want to write that, prime, or you want to write the du over dx, doesn't matter. Okay, let me write this prime. This is, we need to find the derivative of that, and copy v, which is x plus 6 power 4, plus copy u, which is 4x minus 2 raised to power 5, and then derivative of v, which is x plus 6 power 4 prime. Now, using the chain rule, you know how to find the derivative of that. Now you know how to find derivative of 4x minus 2 raised to power 5 using the chain rule. Again, so first derivative of the mother function here, which is 5, leave the baby inside, raised to power 4. And now differentiate the baby inside, which gives you 4 minus 0, which is simply 4. Okay, so I can write that as 20 4x minus 2 raised to power 4, and then x plus 6 power 4 plus, copy that, 4x minus 2 raised to power 5, and then derivative of that. Let me do it here. So now derivative of x plus 6 raised to power 4. So first you differentiate the mother, which is 4 times x plus 6, leave the baby inside, and then find the derivative of the baby. So differentiate the baby now, so which is 1. So basically you get here 4x plus 6 raised to power 3. And that's it, we're done. If you want to simplify it, go for it, but you don't need to do that, by the way. Okay, you can simplify it just for fun. And if you simplify, if you want to simplify for fun, it will be, I think the final answer will be something like 4 x plus 6 cube, 4x minus 2 raised to power 4, and 9x plus 28. I believe if you simplify it further, you will get this one, but like I said, you don't need to, but you know, if you want, just for fun, go for it. I don't have any problem. Is there any question so far? Okay, guys, I want you to try part C on your own. So the part C is f of x equals so hint, use chain rule and the quotient rule. Okay, first using the chain rule, you will differentiate the mother function here, which is, you know, the outside function, 6x plus 2 over x minus 5 power 5, and then you find the derivative of this part, x plus 2 and x minus 5. Now, use the quotient rule here, use quotient rule. Okay, and this part will be 6x plus 2 over x minus 5 raised to power 5, and using the that's going to give me, you know, this is your u, and so d over dx of x plus 2 over x minus 5. So we know the chain rule is this, prime prime, so u prime is 1, copy x minus 5, and minus u is x plus 2, copy u, and derivative of v is 1 over v square is x minus 5 square. So you're going to get x minus 5 minus x minus 2 over x minus 5 squared, which is minus 7 over right? We get that. So your final answer, you can write it down. Somebody already wrote the answer in the chat room. Thank you very much. And so the answer will be negative 42 x plus 2 raised to power 5 over x minus 5 raised to power 7. Okay, that's what we got. Now, this is the idea. Now, the question is there any applications in the real world? Why we're doing all of these things, right? Is there any application? Well, every math, no matter how abstract they look like, they always find some applications in the real world. So we will see some real world applications of this. Here is one example 6. And we'll come back to example 3 later. Suppose a sum of $1,500 is deposited in an account with an interest rate of R% per year compounded daily. At the end of 5 years, the balance in the account is given by this expression: A equals 1,500 bracket 1 plus R divided by 36,500 raised to power, the whole raised to power 1,825. Find the rate of change of A with respect to R if R is 6%. So what we need to do here is we need to find the rate of change. We know that rate of change is given by the derivative, right? So basically what we want to do is we want to find the derivative in this case. Guys, I want you to try on your own. Find the derivative of this functions, okay? So here, so given A equals 1,500, 1 plus R divided by 36,500 raised to power 1,825. By the way, this is the formula that you learn in your high school in order to find the interest, okay? Compounding interest. So then you'll find the derivative, which is, you know, this is a function, A is a function of R. I'll write A of R. So A prime of R will be, I'll leave it to you. You did the derivative of the mother function, leaving the baby inside. And then if you want to differentiate inside, so inside part, differentiation derivative of the baby is 1 is 0, plus derivative of that will be 1 over 36500. And guys, I don't have calculator, and those who have calculator, please help me. I trust that if I simplify this one and this one, it gives me 75, I believe. And then you left with 1 plus R divided by 36,500 raised to power 1,824. Okay, so we found the derivative here using the chain rule. Now, find the rate of change when R is 6%. So when R equals 6%, the rate of change, even though it just say rate of change, then this represents the instantaneous rate of change, by the way. Rate of change, which means the derivative. The rate of change is given by A of r is 6 equals 75, 1 plus 6 divided by 36,500 raised to power 1,824. And if you use your calculator, please help me. How much do you get? My calculator tells me this is $101.22, but I want to verify with your answer, guys. Okay, yes, great. Thank you. So this is the rate of change. Is there any question, guys? Okay, the last example for this section is example 3, find the equation of a line tangent to the graph. Okay, we need to find, remember, we need to find the equation of a line. Equation of a line. What we need is to find the equation of a line. Here is the formula. Equation of formula is y minus y1 equals m times x minus x1. So basically we need a slope m, okay? And then we need a point. If we have these two things, we can find the equation of a straight line. So first of all, x is given 2. So let us find what is y, because we need a point, okay? First, to find equation of line, tangent line, we need to know two things. Okay, two things. One is slope, and the second one is a point in the line. So remember, this is always helpful. Keep that in mind all the time throughout this course. So this is the hint actually. Our solution is start from here. First of all, to find the point, we need to find the point. To find point, when x equals 2, your y value is given by h of 2 is given by 1 over 3 times 2 minus 5 square. And that is going to be how much is that? 1. So we have a point 2 and 1. Now to find the slope, slope of tangent line. Okay, remember, slope of tangent line basically means the derivative. We know that. Slope of tangent line is given by the derivative. So we need to find the derivative of f. Again, so derivative of h is, use the, find the derivative of the mother function, leave the baby inside, which will be 2, 1 over 3x minus 5 raised to power 1. We leave the baby inside, and then we need to find the derivative inside. So find the derivative of d over dx of 1 over 3x minus 5. So I trust that you can use the either you can use the quotient rule, or you can use the power rule, doesn't matter. So using quotient rule, a lot of time when this kind of function, this kind of function is given, then it is always easy to find the derivative this way. Okay, let me just show you there quickly. So this means, 1 over 3x minus 5 we can write this as d over dx of 3x minus 5 raised to power negative 1. Because we already know the chain rule, instead of using the quotient rule, the chain rule is much easier, because you know, it's just like differentiate the mother function and then leave the baby inside and differentiate the baby, right? So differentiating this, you're going to get negative 1, 3x minus 5, and negative 2, and then differentiate the inside, which gives you 3. So basically, this will be negative 3 over 3x minus 5 raised to power 2. If you want, you can use the quotient rule, but I'm using the chain rule here, and I think that makes sense, okay? So we found the value for that is so what we got here is that 2 raised to 2 over this guy is 3x minus 5, and then this part is negative 3 over 3x minus 5 raised to power 2 square. So if you simplify it, you're going to get negative 6 over 3x minus 5 power raised to power 3. So when x equals 2, because x is given 2 here, as you can see, when x is 2, your slope of the tangent line, slope of tangent, you can write that as m, which is actually h prime of 2 is given by, you can calculate that easily. If you substitute that value here, what do you get? Negative 6 over 3 times 2 minus 5 raised to power 3. How much is this? That is going to be negative 6. Thank you. Okay, some people already got the answer. Great. Now we have both things that we need to find the equation. Therefore, equation of tangent is given by, with slope m equals negative 6, and through the point, the point is given 2 and 1. So you can suppose that as your x1, y1, and m is there. So your formula is y minus y1, m times x minus x1. That's going to give you y minus y1 is 1 equals m is negative 6, x minus x1 is 2. And simplifying this, you're going to get y equals negative 6x plus 13 is the equation of the tangent line.